Okay, you're given this function, p of a polynomial function, p of x. I won't repeat it. You're asked to write it in form as a linear factors. Here's the original. Here is q of x written in factored form. Well, this factor is not linear. You could write it as x minus 6i times x plus 6i. And here's kind of proof that those two functions are equivalent. And here are the roots. When you put in -3 for x, you get a result of 0. When you put in 4/3 for x, you get a result of 0. When you put 2 in for x. Question is, how did we get from here to here? Well, we'll go to board 2 and talk about it. Here's p of x. If 6i is a root, then -6i is also a root. And that means that x minus 6i and x plus 6i are factors of the original polynomial function. And then there's some other polynomial out here that's also a factor. If I multiply these two together, I do get x squared plus 36, because 6i squared is 36i squared. So we'd have x squared minus 36i squared, but I squared is -1. So to find out what this remaining polynomial is, we got to use long polynomial division. I'm going to divide x squared plus 36 into the original p of x. Shown my work here. You can follow along. Left a placeholder for x here. Every other power from 5 down to 0 is represented. And by the time we better get a remainder of 0, otherwise x squared plus 36 is not a factor. But there's your remaining polynomial factor, 3x cubed plus x squared minus 22x plus 24. Now, are there any values of x that you can substitute into here that will give an answer of 0? Because if there are, then x minus that number will also be a factor of the polynomial. So we can use the rational root theorem. The values of p are the factors or the multiples of 24. And we should have plus or minuses on all of these. And the factors of q, the leading coefficient, are 1 and 3, again with plus or minuses. And so here is a table where I'm using synthetic division to try these numbers, p over q. First, I'll try all the possible values of p where q is plus or minus 1. So if I try 1 and use synthetic division, remember I'm bringing down this 3, taking 1 times 3, adding the result to the next numerical coefficient, and I continue that process till I find out that p of 1 is, or p of this function or factor is going to be 4. -1, no, but if I put 2 in, using synthetic division, I get a remainder of 0. That means x minus 2 is a factor. And the remaining polynomial factor is 3x squared plus 5x minus 12. And here I factored that using the split the middle or the AC method, finding two numbers that multiply to give -36, a times c, and have a difference of plus 5. And there they are right there, -4 and plus 9. Split the middle, factor by grouping, 3x minus 4 times x plus 3 are the remaining factors. There you go. And again, if you want to really represent this as a product of linear factors, it would be x minus 6i times the quantity x plus 6i. There you go. Hope that helped. If you have any questions, post a comment.